So we're going to talk about the temperature dependence of diodes. So recall your relationship between current and voltage for a diode. And as we said before, it was an exponential. Okay? So this property is true for some temperature, T1. Okay? As we change the temperature, let's say we increase it, this property is going to change. So instead of this curve, what we're going to have is a different curve. Okay? It's shifted to the left. This is at temperature T2 greater than T1. So what does this mean? What it means is that we've shifted it. We're going to shift the forward voltage for our diode, right? So the forward voltage here, if we have forward voltage 1 at this temperature, by increasing the temperature, we're going to shift our forward voltage. We're going to have another forward voltage here, too. So we can use this temperature sensitivity of the forward voltage of diodes to detect changes of temperature. We can actually use it to measure temperature. What we're going to do in your design challenge is use this property to control the toaster you made last week. Okay? So let's work through that circuit, the basics of that circuit at least. So let's think about having two diodes, okay, and connected through a resistor to ground. So this is one diode. Let's have a second one. I'll draw it over here, connected through a resistor. Okay, and let's have both of them be sourced with 5 volts. Okay. So, and then we can match these two resistors. Let's keep them at the same level, same values. Okay. So in principle, these are the same diodes, the same resistors, the same voltage supply. The voltage that we measure here should be identical, right? Because we're measuring the voltage drop across the resistor from this point to ground. These are the same diodes. That forward voltage should be the same. It should be around 0.6. Okay? So what we can then do is measure each of these voltages. Okay? And let's actually do this with colors. I'll say this is here. And what we can then say is take these voltages and put them to a comparator. This is our op-amp, and we're going to use it as a comparator. We're going to take the voltage from this one, put that to our non-inverting input, take the voltage from this line, put it to our inverting input. Okay? And then we can monitor now the output voltage here. And what is this output voltage going to reflect? It's going to reflect the difference between the forward voltages here, right? So at a given temperature, both these diodes are sitting in the same room. They should be experiencing the same temperature. They should have the same nonlinear relationship. These voltages should be matched, right? So this V out should be just kind of flickering back and forth, be right on the edge of going from plus 5 volts to minus 5 volts, just going back and forth. But what you can see then is if you heat up one of these diodes, right? So if I take my hand or your finger, grab onto that diode and heat it up, okay? As that diode heats, it's going to shift the property here, change the forward voltage, right? And all of a sudden, there's going to be a difference between these two, between the forward voltages on these lines. All of a sudden, there's going to be a difference between these two, and our V out is going to swing either positive or negative and stay that way as long as there's a temperature difference between these two, right? So we can use the output V out here to say, okay, which one of these diodes is actually hotter than the other? So we can use one as a reference to say, okay, this is the temperature of the room, and then we can use the other as the sensor, right? So in particular, for your design challenge, you can use this as the sensor for the grain of wheat toaster that you made last week. And you can use this diode then to be sensitive to, as that toaster increases, you can monitor that temperature and then decide to do something afterwards, which is what you're going to do for your design challenge. Okay? So one little note here, though, right? You saw in previous weeks, these resistors, even if you choose them as being the same, right? There's a tolerance to the value of the resistor that you see. There's some slop, right? Plus minus 5% in the actual resistors, the values you see here. That difference in resistors, okay, is going to cause a difference in currents that flow through these, right? That difference of currents might cause a small change of the forward voltages that you see here, right? So even if these are experiencing the same temperature by sitting in the room, there might be a small difference of the voltages here. Moreover, something we haven't talked about with the op-amps, but the two inputs can be sitting at slightly different voltages, even with nothing connected to them. Okay? So what you need to do is be able to regulate that, because you want this circuit to be sitting here right on the edge of the edge of going positive or negative when these two things are at the same temperature, when they're in the same environment. So instead of just having this circuit with 5 volts across these resistors, what you can do is use a potentiometer. Okay, so you could have interesting, lines coming down to each of these. Actually, let me change that. Sorry, so we're going to have a potentiometer with 5 volts coming in, and then that can go down to your 2 different diodes to ground. Okay, so then you can trim your potentiometer so that you can change which resistance is going on each of these lines, basically trimming these 2 resistances so that these 2 voltages are matched to one another and that this is sitting on the edge. And when they're sitting on the edge, right at that cusp, then you can heat one of these and it will flip to positive or negative as you've designed your circuit. Okay? So this is the basic circuit you're going to use for your assignment, but it's also going to be used as a basic component within your design challenge as well. And you can see that it integrates our knowledge of op-amps that we talked about in the first part of this week, as well as the knowledge of your diodes as well as potentiometers as well. So all of these different skills you've been accumulating are going to be useful in this design challenge.